Assalamualaikum warahmatullahi wabarakatuh. My name is Hvac from BMMV, class 11. I would like to talk about the literature review of Hvac. Hvac stands for Heating, Ventilation and Air Conditioning. It uses the different system for moving air between indoors and outdoor areas, such as in rooms or office, which is along with heating and cooling both residential and commercial building. Hvac is a system that keeps you warm and cozy in the winter and feeling cool and fresh in the summer, and it is also a system that filters and clean indoor air to keep your health and maintain humidity at its comfort level. Hvac is more than just warming or cooling a space. It is served to improve indoor air quality and provide comfort for everyone. The discussion we are going to discuss out the main Hvac device in the house with air conditioner, with an explanation for each component and function of the Hvac system, such as the cycle and type of air conditioner.
Hi, my name is Ni Ahmad Nazran bin Ni Ahmad Khan. So I will explain about the refrigeration cycle. The refrigeration cycle starts and ends with the compressor. The refrigerant flows into the compressor where it is compressed and pressurized. At this point, the refrigerant is a hot gas. The refrigerant is then pushed to the condenser, which turns the vapor into liquid and absorbs some of the heat. The refrigerant then proceeds to the expansion valve, where it expands, losing pressure and heat. The refrigerant coming out of the expansion valve is cold and slow due to the loss of pressure. It enters the evaporator in a liquid state, where the exchange of heat takes place, thus cooling the load inside the refrigerator. As the gas cools down the load, it absorbs the heat, which turns it into a gas. The gas is then pushed back into the compressor, where it can start the cycle again. Next, I will explain about the comparison of inverter and non-inverter air conditioner. The key difference between the two air conditioner types lies in the compressor's ability to regulate the speed of its motor to adjust the room's temperature. Once a room is cool, inverter air conditioners lower the speed of the compressor motor to save energy and refrigerant required to cool the air. In comparison, non-inverter motors only run at full speed, then shuts off when the room temperature reaches the desired temperature. The repetitive on-off process creates more noise and consumes more energy. That's all from me. Thank you.
Today I will explain about parts of split air conditioning system, which is the outdoor unit. First, we have a compressor. The compressor will increase the pressure of the gas by reducing its volume. It will compress the refrigerant gas and then transfer it into a liquid form. Next, we have a condenser. Condenser will cool down the air by exchanging heat with the environment. It will circulate the air across the coil to facilitate heat transfer. Lastly, we have a fan, which it will circulate air through the house and transferring hot air to the outside of the house. Next, I will explain about the indoor unit of a split air conditioning system. First, we have an evaporator coil, which absorbs heat from the surrounding and converts it into a refrigerant to chill the air. Next, we have an air filter, which it will preventing dust, dirt and other solid particles from entering the air conditioner. And lastly, we have an air blower, which it will distribute the cool air throughout the space. Thank you.
Assalamualaikum. I am Muhammad Nur Iqmal, and today I will be presenting about our group result and analysis. For result and analysis of the assignment, we analyze the difference between inverter and non-inverter unit. We analyze on 4 different things, that is compressor, performance, efficiency, and cost. So, what is inverter? The inverter technology works like an accelerator in a car. When compressor needs more power, it gives it more power. When it needs less power, it gives less power. With this technology, the compressor is always on but draws less power or more power depending on the temperature of the incoming air and the level set in the thermostat. The speed and power of the compressor is adjusted appropriately. So, how does it work? For compressor, the non-inverter compressor uses a simple fixed speed on and off operation. This means that the compressor works at peak load until it reaches the temperature that we have set. After that, it turns off completely where there is no middle ground. While an inverter is a device that controls the frequency of the incoming electrical current that goes to the compressor, which allows the compressor to operate at a variable speed. After reaching the desired temperature, the inverter compressor does not completely shut off. Instead, it operates at a lower speed to maintain the set temperature. For easy understanding, we can compare it to a man running. For inverter, the man run at an appropriate pace is maintained. A runner can continue without wasting energy. Then, for non-inverter, the man starting and stopping hard running, resting, then starting and stopping once again, which will use more energy. Next, for the performance, inverter units are more versatile thanks to their compressor system. It will function based on the settings for the room and the thermostat. It adjusts their process based on the current temperature in the room. On the other hand, a non-inverter aircon will do a fine job but will operate on a fixed level. The third one is efficiency. Inverter aircon units have controlled compressor speed. At the same time, their speed can change when required. Inverter helps in limiting energy consumption because of how their compressor works. Therefore, it is easy to see why an inverter unit trumps the non-inverter units. The process of non-inverter can result in excessive use of energy, which consumer may end up with unnecessary expenses. Also, because of energy efficiency of inverter units, they are regarded as the eco-friendly choice. They can lessen your energy by up to 46% compared to the non-inverter air conditioner. And lastly, in terms of cost, as we know, the non-inverter are much cheaper, which is why some homes choose them. Although they can be noisy and inefficient in saving energy, they perform adequately in cooling any space. But still, in terms of long-term costing, an inverter aircon is the perfect unit to demonstrate the cost-saving benefit. Although it costs more at first, but it will help you save in the end. The unit will pay for itself in the long run, unlike the non-inverter. Next, I will talk about comparison between inverter and non-inverter based on energy and cost saving. Firstly, from the first figure, the comparison is made between 1.5 horsepower inverter and non-inverter when it operating 8 hours per day based on cumulative power consumption daily. The air conditioner is tested on a 16.5 meter square room size, then it is set to the 25 Celsius, and the high fan speed at outdoor temperature is 33 Celsius. From the above study case comparison, it shows that the inverter units provide more electricity cost saving compared to the non-inverter unit. Then, from the second figure, the analysis is based on payback period of inverter and non-inverter units. When inverter air conditioner is compared to non-inverter air conditioner, the inverter conditioner can save up to 50% more energy and up to 65% more with extra features like dual human activity sensor, light sensor, and temperature wave. From the graph shown, comparison to non-inverter type and inverter type with a 65% energy saving is the lowest payback periods of 3.42 years, followed by inverter model with 50 and 35% energy saving. As a result, the percentage of energy saved has a considerable and positive effect on payback periods. In the case of 65% energy saving, after 3.42 years and onwards, the consumer gains significant cost saving if they are using this inverter type with 65 energy saving compared to standard non-inverter type. Thank you. That's all from me.
My name is Muhammad Izwan Aiman. So I'm going to present about the device that consume large energy in Hvac system for result and analysis. A conventional refrigeration system is made up of 4 fundamental parts, which is compressor, a condenser, an expansion device, and evaporator. The compressor is in charge of compressing superheated vapor from low to high pressure, or it is called evaporative pressure and condensation pressure. Following that, the high temperature refrigerant fluid flows through the condenser. The compressor is housed within the condenser unit, and the component that initiates the chain reaction is responsible for cooling the refrigerant. Heat is removed from the air as it passes through the evaporator unit at room temperature. The heat from the air is transferred to the refrigerant, which is subsequently introduced into the compressor. The refrigerant is then compressed, condensing into a fluid before being released under pressure. The refrigerant is considered very hotter than when it arrived, but the heat is dispersed by the condenser coils. The refrigerant is cold again by the time it reaches at the end of the loop, and it is injected into the evaporator coils. So this cycle will continue indefinitely as long as the air conditioner is switched on. Certain Hvac systems have compressors that reverse the process, resulting the hot air instead of cold air. We can see that the compressor is the most crucial component of the refrigeration cycle. This is why it is commonly referred to as the heart of the air conditioner. The majority of the power required by the air conditioner is attributable to the operation of your own compressor.
For discussion and conclusion, we can say in a nutshell, inverter aircons are advanced machines that utilize a controlled compressor, while non-inverter air conditioners are less advanced with a default compressor, though generally less expensive and much more common. Then, the inverter aircon and the non-inverter aircon are distinctive from each other in a way such as functionality and how each unit works and their built-in feature. Next, the inverter aircon is more likely choice for when you need to save electricity as it limits energy consumption. And the fourth, non-inverter can cause excessive and unnecessary use of energy and will often inadvertently rack up your electric bill. Next, inverter aircon are inherently more energy efficient and will help you save on your monthly bill. Also, because of this energy efficient feature, inverter aircons are regarded as an environmentally friendly system as it uses 30 and 50% less energy than a non-inverter type. So, last but not least, the inverter aircon is definitely the better investment and the more reliable choice for the house. And the non-inverter aircon is much more accessible, especially for families who will not be using the air conditioner too often. That's all from our presentation. Thank you.